The teaching of Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, this is Saurav here and welcome to another session for the Chemical Kinetics lecture. This is the second lecture and for grade 12 students. I'm Saurav Goswami and welcome to this lecture once again. Hello Ajay, hello Preetam and hello Anat, hello there. So very warm welcome to everybody, and as you guys know that we have until now done an introduction to this topic. And this topic is quite interesting, बहुत interesting topic है, and this topic has less of chemistry, more of maths, and basically like बहुत elementary maths use होता है इसमें. So today's session is on order, molecularity and integrated rate law. In today's session we would be learning these things. So we might not be able to complete all these three things, तो next class में हम लोग जो थोड़ा बचा रहेगा उसको cover कर लेंगे. So hello Jatin, hello Pankaj. So let's start today's session, and before going on to that, I'd like to tell you that please do like, share and subscribe the channel and spread the word around about the classes that we are conducting. And with that note, let's see how much of things we have completed. We have completed rate of reaction. We have discussed that what is the relation between rate of reaction and rate of decomposition and rate of decomposition of reactant and rate of formation of products. So everybody who remembers what is the relation between rate of reaction, rate of decomposition of reactant and rate of formation, please do say, write a yes in the comment section or in the chat box that you remember that how is this related to the stoichiometry of the reaction and rate of decomposition, rate of formation. So with that thing in mind, let's take the first example. We start the class with an example. The example is this. Okay, let's read the question. Ammonia and oxygen react at high temperature in the following manner. So 4 moles of ammonia react with 5 moles of oxygen to give NO, 1 mole of NO and 6 moles of H2O. In an experiment, the rate of formation of NO is given as 3.6 times 10 raised to minus 3. We have to calculate the rate of disappearance of ammonia. Okay, we have to calculate the rate of disappearance of ammonia. How do we solve the question? So the question is very simple, very simple. How do we solve this? So for this reaction, what is being asked? We have been asked about ammonia and information is given about NO. So what is the relation between ammonia and NO? Can I say that del of concentration of NO upon del T, which is equal to 1/4 NH3 upon concentration upon time. Can I say this? Okay, I can say this because 1/4 of this gets consumed in the same time in which 1 unit of this gets formed. So this is the relation that we would arrive at. ये हमने पिछले क्लास में किया था. Okay, ये हमने पिछले क्लास में किया था. So what is given is that this rate of formation of NO is 3.6. 3.6 times 10 raised to minus 3. Okay, and this has to be multiplied by 4 so as to obtain rate of disappearance of NH3. The right answer would be 6 for 24 and 4 3 12, 14.4 times 10 raised to minus 3, or you can also write it as you can also 1.44 आप लिख सकते हैं, 1.444 times 10 raised to minus 2. You can also write this. Okay, you can write in any way possible. So this is the answer for this first question. So I'm just writing 14.4 times 10 raised to minus 3. Okay, and this unit will be molarity per second inverse. Molarity per second inverse. Okay, let's look at the answer to the second question. Rate of formation of water, NO का दिया है, water का निकालना है, तो water क्या होगा, 6 times हो जाएगा. So 3.6, this will be 3.6 times 6 times 10 raised to minus 3. This will be equal to 6, 6, 36, 6, 3, 18, and 21, 21.6 times 10 raised to minus 3 molarity times second inverse. Okay, this will be the answer to this question. Very simple question for the starters. This is, तो वार्म अप के लिए हमारे पास ये क्वेश्चन मिल गया, सिंपल सा क्वेश्चन है, ठीक है. So let's look at the solution. Solution मैंने यहाँ पे, so the solution is also here. So rate of disappearance of ammonia is 3.6 times 10 raised to minus 3, and you can see that the reaction can be written as like this. Yeah, minus sign, disappearance के लिए minus sign. When it is written as disappearance, it is already evident. Okay, O2 by dt, and okay, the reaction was not balanced. Okay, there is a small issue over here. The reaction was not balanced. तो हमने reaction balance करना चाहिए था. So okay, the reaction was not balanced. So हमारे से mistake कहाँ पे हो गया? Okay, what mistake did we do? Our reaction was not balanced. So if the reaction is not balanced, the rate of disappearance of ammonia should become equal to rate of formation of NO, and rate of formation of H2O will be equal to 1 by 4, 3 upon 2 times rate of formation of, a very important, yeah, very good, lamp camper. So this gives us a very important like lesson, that whenever we have a reaction where such a question is given, we have to always check that the reaction is balanced. Okay, unless the reaction is not balanced, our answers, that whatever we would be getting would be incorrect. So our answer would be for dH2O by dt will, or rate of formation of H2O will be 3 by 2 times, so that is 6 by 4 or 1.5 times 3.6. So answer हो जाएगा ये, and yeah, and for NO it will be for NO it will NH3 it will be exactly the same as that of NO. Okay, let's look at the next question. So first thing that we have to do from now onwards is to check whether the reaction is balanced or not. First balanced, and then we will go to that. Okay, so the following reaction was carried out in water. Cl2 plus 2I minus gives rise to I2 plus 2Cl minus. Is the reaction balanced? बताइए, is the reaction balanced? Yes. 2 chlorine atoms on the other side, 2 mass is balanced, yes, correct. The initial concentration of I minus was 0.25 moles per liter, and the concentration after 10 minutes was 0.23 moles per liter. Calculate the rate of disappearance of I minus and rate of appearance of I2. Okay, rate of disappearance of I minus and rate of appearance of I2. कैसे solve करना है इसको? So what we have to do is we have to just see that the rate of disappearance of I minus. So I minus is written as so initial concentration of I minus is 0.25 moles per liter. So this is initial, final is 0.23 moles per liter. Okay, this is the final one. Okay, what is the time that it takes for this change? The time that it takes is 10 minutes. Okay, so can you tell me what is the answer to this? 3.33 times 10 raised to minus 5. Calculate rate of disappearance of I minus is 3.33. So this will turn out to be 0.02 divided by, okay, you have calculated in terms of Anit, your answer should have units. Okay, unless and until you have units in your answer, it is incorrect. Your answer should be in with units, because this is given in terms of minutes. Generally what we do is we convert it into second inverse. Okay, it is in moles per molarity per second. Very good. If it is molarity per second, then what we can write is the rate will become equal to rate of disappearance of I minus will be written as 0.02 divided by time, which is 10 times 60 moles per liter. Okay, so let's see, you have calculated the answer. So let's look at the answer. So 0.25 minus 0.23, 0.02 moles per liter, time is 10 minutes. So it will be 0.002 moles per liter per minute. Okay, moles per liter per minute. For I2, it will be written as what was the reaction? Sorry, the reaction was this. I2 and I minus are related as 1 by 2 I minus is equal to, it will be written as like this. Rate of disintegration of I minus by 2 will be written as rate of formation of I2. Okay, ठीक है, exactly same चीज हमें वहां पे लगा देना है, आंसर ऐसे ही आ जाएगा. So I minus is obtained over here, I2 by 2. So this is the answer, 0.02 to 0.001 moles per liter per minute. How are you getting 10 raised to minus 5 is questionable, because how are you getting for 10 raised to minus 5? The answer should turn out to be, आप इसको 60 से divide कर रहे हो ना, so that's एक बार check कर लीजिए, that should you be getting 10 raised to minus 5. Okay, I'm not very sure of the units that you have used, because this turns out to be 2 times 10 raised to minus 3 moles per liter per minute, and if you divide it by 60, it will turn out to be 1 by 3. Yep, 10 raised to minus 5. Yes, correct. ठीक है, 10 raised to minus 5 आ जाएगा. Clear? So the next question. So this part is clear. I guess this part is clear. You have a clear-cut understanding. But you have a clear-cut understanding of what is rate of reaction, what is rate of decomposition, and what is the rate of formation. With that idea in mind, let's take a question, and this there's a problem that you have to solve. You have 4 options. The question is this: the concentration of a reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Okay, 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of reaction using units of time as seconds. Okay, average rate of reaction using unit of time in seconds. Lamp camper, please ask your dad to write to me at saurav.goswami@vedantu.com. We'll be happy to have a conversation. Okay, so बताइए, what will be the answer? Change in concentration is given as 0.03 to 0.02 molar. 25 मिनट्स में हो रहा है, आपको निकालना है मोल्स पर लीटर पर सेकेंड में. सो 25 टाइम्स क्या हो जाएगा? 25 टाइम्स 60 आप कर दोगे. सो चेंज कितने का हो रहा है? व्हाट इज द चेंज? 0.01. सो 0.01 अपॉन 25 टाइम्स 60. The right answer will turn out to be, कितना होना जाना चाहिए? So this will be 25 times 60 is 15, I guess 0.01 upon 1500. Your answer should turn out to be so आप इसको लिख सकते हैं, I guess answer should be 100. आप इसको 100 लिख दो और नीचे और एक 100 लगा दो. सो ये हो जाएगा कुछ 6.6 and this is 666. In my opinion, answer should be D. The answer should be D. Answer will not be B, the answer will be D. Okay, answer will be equal to D. Very simple question. You just have to see the change in concentration divided by the time, which is to be taken in terms of second inverse, and the answer will turn out to be D. Clear? So with that, let's move on to the next thing. The next thing is, what is rate law? Okay, एक reaction आपको दिया गया है. For a reaction, for a specific reaction, for any reaction that takes place in chemistry, you can always identify rate. Either the rate will be very high or the rate will be very low. For a reaction which is proceeding at an intermediate rate, the rate law tells us the relationship between the rate of reaction and the concentration of reactants. Okay, so if you are taking a reaction, for example, Haber's process, ammonia and nitrogen and hydrogen react with each other to form ammonia. Now in this case, reactant is nitrogen, reactant is hydrogen. So how is the rate dependent on the amount of nitrogen takes place in the presence of sunlight, and it's an explosive reaction. Okay, so for not letting the reaction take place explosively, we store hydrogen and chlorine, or the reaction is performed in brown bottles, or where the amount of sunlight that can go in will be really cut down to a very small level. Intensity बहुत कम कर देते हैं. But let's say the reaction takes place. You would find that though H2 and Cl2 combine to form HCl, and you might think that if I increase the amount of hydrogen, the rate will increase, and if I increase the amount of chlorine, the rate will increase. That would happen. However, you would see that the change takes place constant. There's a constant change. Okay, so it turns out, experimentally it has been identified that the reaction turns out to be of zero order. We'll get to that कि वो चीज़ क्या है. लेकिन अगर मान लो कि ये reaction दिया गया है, let's say ये अगर reaction दिया गया है, then for this reaction can I write if I want to write average rate, so average will be written in this form: minus 1/2 del N2O5 upon del T 1 just del O2 upon del T. I can write it like this. Rate means the speed of reaction. Yes, rate means the speed of reaction. If I want to write for instantaneous, I had told you yesterday in the last class that average means for a considerable length of time. Instantaneous means specifically at a given moment. It will be written as minus 1/2 d of N2O5 upon dt, which is equal to 1/4 d of NO2 upon dt, so on and so forth. Okay, will be d of O2 upon dt. But if I want to write the rate, this is not the rate law. Remember, this is not the rate law. This only tells that the rate of reaction is dependent or can be calculated mathematically like this. This is not the rate law. The rate law will be written like this. The rate law will be written like this. Rate law will be written as proportional to the concentration of reactant to the power a certain number. This is the rate law. Okay, rate law and rate expression. Yes, Priyu, this is very important. This expression tells us that how rate of reaction is related to the rate of decomposition and rate of formation. This expression just tells us that. But how is the rate dependent on the change of concentration? ये हमें नहीं बताता है. Okay, power of 2 I really don't know. Okay, power of 2 I really don't know. However, this reaction power 1 होना चाहिए, लेकिन ये power क्या होता है ये हम बाद में जानेंगे. Okay, this reaction only tells us that if this value is given, how can we calculate the rate of reaction? If this value is given, how can we calculate the rate of formation of NO2? But it does not tell us that if I double the concentration of N2O5, whether the rate will also get doubled, or whether the rate will become 3 times, or the rate would not change, or the rate will become half. It has not been told by this equation. This is the rate law. Okay, this is the rate law. You must have read in organic chemistry that there is a reaction known as SN1 reaction. सुना है आप लोगों ने? In organic chemistry you must have read a reaction known as SN1 reaction. सुना है आप लोगों ने? Yes? No, in SN1 reaction you say that there is a this is the reaction you say that this is a nucleophilic substitution reaction. It seems क्या दिखता है कि there are two reactants. It looks like there are two reactants, है कि नहीं? बताइए. In SN1 reaction, it looks like there are two reactants. This is the alkyl halide. This is OH minus, which comes from KOH or aqueous NaOH. It looks like there are two reactants. But when I write the rate law, if I write the rate law will look like this. The rate law will look like this. It will be written as this. Rate is proportional to alkyl halide to the power 1 OH minus to the power 0. Okay, alkyl halide to the power 1 and OH minus to the power 0. It means that if I increase the amount of OH minus, it would not affect the rate of reaction. Okay, what does this tell us? That if I increase the amount of OH minus, it does not increase the rate of reaction because this power is 0. इसको मैं double भी कर दूंगा तो power 0 होने के कारण ये 1 हो जाएगा. But if I double this, the rate will get doubled. So this is what rate law tells us. Okay, just by looking at a reaction, you cannot tell the rate law. Because you can see that the prefix is 1 over here. यहाँ पे prefix क्या है? 1. It looks as if 1 mole of both of them are taken. But the power that I have used is 1 and 0. So 1 and 0 powers have come from an experimental deduction. Remember, these powers 1 and 0 have come from the experimental deduction, and this experimental deduction is known as order of a reaction. Okay, this experimental deduction is the order of a reaction, the dependence. इसको हम बाद में पढ़ेंगे, but rate law ये होता है. And rate law, can I say this is determined experimentally? So never ever say that it is determined theoretically. It is always determined experimentally. Let's look at what is order. So what is order? Order of a reaction tells us that in the rate law, how is the rate dependent on the concentration? The order of a reaction refers to the dependence of rate on the concentration of each reactant. Okay, let's look at a very simple example. Let's look at a very simple example. Assume that there is a classroom of boys and girls. Okay, there's a classroom filled with boys and girls and a teacher is trying to teach. ये लड़के जो हैं वो बहुत बदमाशी करते हैं. They make so much of nuisance that the teacher finds it very difficult to take a class, because they will just get involved in fights, they will just throw chalks at other people, they will just eat the tiffin boxes. So half of the time teacher is just shouting at them and the process is taking place very slowly. So class में जो पढ़ाई हो रही है, let's say we call that a reaction. Okay, the rate at which the teacher is teaching is to be determined. The rate at which the teacher is teaching is to be determined. So rate of teaching should be proportional to whatever things are present in the class. What is the, when a teacher is teaching, who it is teaching? Teacher is teaching the students. Students are boys and girls. So boys के concentration पे, boys के numbers पे, and girls के number पे depend कर रहा है. Can I say this? Okay. Now, if the number of boys is increased, what would happen to the rate of teaching? Assuming that the class is really naughty, अगर मैंने boys का amount increase कर दिया, तो rate of teaching will keep on decreasing. Okay, rate of teaching will keep on decreasing. So can I say that the power to which boys amount should be raised should be negative? Can I say that? The power to which, so some negative power, yes, very good Pritam, it will decrease, so this will be raised to some negative power. But even if there is one girl present or there are 100 girls present, the girls are very timid, they are very diligent, they are like always focused on studies. So अगर एक लड़की भी present है या फिर एक से ज़्यादा लड़की present है, उससे फर्क नहीं पड़ता rate of teaching क्या होगा. Rate of teaching ये शैतान लोग decide कर रहे हैं. Okay, so ये power क्या हो जाएगा? 0. So this power is a function of what is happening inside the class. Okay, this power is a function of whatever is happening inside the class, and it will always be experimentally determined. It will always be experimentally determined. So in context of a reaction, there could be more than one reactant. But some reactant may influence the rate, some reaction may not influence the rate, some reactant may influence the rate in such a manner कि उसको आपने increase किया और वो double हो गया rate. For example, let's say we take a reaction A plus B changes to products. A plus B changes to products. Initially, the rate value is 1 times 10 raised to minus 3 moles per liter per second. A का amount 1 है, B का amount भी 1 है. Okay, A amount is 1, B amount is 1, and the rate is this. Now I double the amount of A, keeping this constant. I am getting the value as 4 times 10 raised to minus 3. I keep A constant and double this. I am getting 2 times 10 raised to minus 3. So can I say looking at this, ये इनके concentrations and ये rate दिया हुआ है, can I say looking at this that the rate should be proportional to A to the power 2? Can I say that rate will be proportional to A to the power 2 and B to the power 1? Because I can, if I solve it mathematically, then what I do is I divide first equation by the second equation. Sorry, I divide the third equation by the first equation. I will get the order of B. Okay, I will get the power to which B is raised. So invariably all reactions will be written like this. Rate is proportional to A to the power M and B to the power N. It will be written like this. But to what is this number M and N will be dependent on how are we doing the experiment. If we are doing the experiment and we are getting this data point, using that we will identify it. So did the reaction have a prefix 2 for A? No. Did the reaction have a prefix 2 for A? No. Did the reaction have a prefix 1 for B? Yes. But 1 being the order for B is a coincidence. 2 is again an experimental result. So it is always important to remember that never ever look at a reaction and say that iska order X ho jayega ya Y ho jayega. Okay, don't do that. Now, if it is an experiment, then If it is an experiment, it has to be understood that the order could be, order क्या हो सकता है, क्या वैल्यू ले सकता है? Order can take any value. It can be 0, okay, it can be fractional, it can be negative, it can be positive, it can take any value possible. It can take any value. Okay? Understood? An example of zero order reaction which looks like ki, why wouldn't the concentration affected, is the catalyzed reaction. Suppose this is the surface of catalyst. This is the surface of catalyst. When we have a small, whenever a catalyst is taken, आप catalyst को बहुत कम amount में लेते हो. You take the catalyst in a very, very small amount. Now, when a reaction is being performed, you would see that a catalyzed reaction rate will not increase upon increasing the amount of reactant. इसका reason क्या है? Catalyst पे surface reaction होता है. So the surface is already filled with reactants. Okay? Surface is already filled with reactants and some reaction is happening. Since the amount of reactant that will be filled on the surface will be proportional to the surface area available, if the whole surface area is already filled up, increasing the amount of reactant will not affect active site is totally filled. Yes. Okay. If the surface is completely filled, if the whole surface area is occupied, no matter to whatever extent I increase the concentration of reactant, the rate will not increase. Okay? So one of the example is this. Try to write in the comment section what is an example of a negative order reaction. Negative order reaction एक बहुत important reaction होता है हमारे atmosphere में negative order का. Try to identify that. So please do write in the comment section that what is an example of a negative order reaction. Okay? Let's talk about something else. There's something known as a molecularity. Okay? Now you can see that I have chosen a picture of a football game. Okay? Rate expression, rate law अलग है क्या? Rate expression, rate law अलग नहीं है. मतलब एक ही चीज है. Okay? They're the same thing. This is a football game. Now whenever a football game, you must have watched a football game, played a football game. So you must be seeing that the ball is already being tackled by some players. Okay? At a given point of time, it could be just one player who is tackling the ball. Okay? Is moving the ball from one end or the other end, or it could be more than one people who are tackling the ball. Isn't it? Can it ever happen that negative number of people are tackling the ball? ये number हम बोल सकते हैं क्या? Can it ever happen that the negative number of people are tackling the ball? Doesn't make any sense. Zero number of people are tackling the ball. No. Okay, fractional number of people are tackling the ball. Obviously not possible. Also, let's say the total number of people present on the football field. कितने लोग present रहते हैं? 11 players आप रहते हो, if I'm not wrong, 11 players, 22 players. Out of 22 players, are all 22 players tackling the ball? Are all 22 players tackling the ball? No. The maximum number of players who can tackle the ball at a given instant is at the max probably 4 or 3. उससे ज़्यादा तो लोग tackle नहीं कर सकते. The maximum number will be 4 or 3. So what is molecularity? Molecularity tells us the number of molecules that come together to react in a elementary step of a reaction. Elementary step is a reaction which gets completed in a single step. Elementary is single step. So molecularity tells the number of molecules which collide with each other to perform a reaction. So number of molecules that come together to react or collide in an elementary single step reaction. याद रखो ये सिर्फ single step process के लिए defined है. If the reaction is taking place in multiple steps, then it is not defined. Molecularity is not defined. It is only defined for a reaction which takes place in a single step. So maximum molecularity could be 3. It can go all the way up to 4, but 3 से ज़्यादा देखना बहुत मुश्किल है, क्योंकि it is very very improbable that more than 3 molecules will be so very well oriented that they will collide at one instant. It's not possible. Okay, what is the other feature? The other feature is it is equal to the sum of a stoichiometry 2A plus B, which is giving rise to products. Elementary means 2 molecules of A and 1 molecule of B are simultaneously colliding in a single step process to form a product. So the molecularity will turn out to be 3. Okay, the molecularity will turn out to be 3. Okay, so elementary in this elementary reaction, elementary part is very very important. Okay, now the last and the most important point about this and how does it relate to the order is that order is the same as molecularity for elementary reaction. Okay, very good Akhil. Order is the same as molecularity for a elementary reaction. If there is a reaction which is taking place in a single step, the molecularity will become equal to the order. Okay, the molecularity will become equal to the order. Is that clear? हमेशा याद रखो, molecularity can take up which values? Which values molecularity can take? Molecularity will always be positive whole number values. Always be positive whole number values. It cannot be 0, it cannot be fractional, it cannot be negative. Okay, cannot be 0, cannot be fractional, cannot be negative. Clear? So molecularity and order का ये relation रहेगा. Now suppose this statement is generally given in examinations that I will write the statement. Please tell me if the statement is correct or incorrect. The statement is 0 fractional and negative 0 fractional and negative order reactions are multi-step reactions. They are multi-step reaction. Is this statement correct or incorrect? If it is a 0 fractional or negative order reaction, the reactions are multi-step reactions. Is the statement correct or incorrect? Is the statement correct or incorrect? The statement is correct. The statement is correct. The reason why this statement is correct is because order is the same as molecularity. So in an elementary reaction, if molecularity is +1 and so on and so forth, it will be the same for order. It will be the same for order. But if I take 0 fractional negative, can I define molecularity for that? No. I cannot define molecularity for what other condition if it is a non-elementary reaction. I cannot define, can I define molecularity for this? No, because molecularity can never be 0 fractional negative. Under what other condition molecularity cannot be defined? If it is a non-elementary reaction. So that means all of these reactions are multi-step reactions. Okay? With this note, let's move ahead. Let's take this question. Let's take this question. Question is, determine the rate law and the overall order of the reaction. Determine the rate law and the overall order of the reaction. So for this reaction, if I want to write the rate law would be written like this. Rate will be proportional to CH3 whole thrice CBr to the power m H2O to the power N. Okay, alkyl halide tertiary butyl bromide to the power M, H2O to the power N. How do I calculate M and N? I will use this information. Information given is doubling the concentration of bromide doubles the rate of reaction. If I double this, if I make it 2 times, this becomes 2 times. So M value will be 1. If I double this, this becomes double. That means M should be 1. Doubling the concentration of H2O does not affect. So if I double this in a separate case, in this case this is constant, in this case this is constant, and if I double this no change. Okay, so what I'm doing is I am keeping one of them constant, changing the other, and I'm calculating M and N. So M turns out to be 1, N turns out to be 0. The overall order becomes 2. 1 and 0, M is not 2, M is 1. M is 1. I am doubling this, rate is getting doubled, so M is 1. So remember, overall order, the sum of this is the overall order. Overall order is 2. There's something known as partial order. Partial order is with respect to each of these reactants. So partial order with respect to bromide is 1. Partial order with respect to H2O is 0. Okay? Is that clear? Now, if you are being asked this question that what is the molecularity of this reaction, you would say the molecularity of this reaction is not defined because ये reaction मुझे मालूम है ये 2 step में चलता है. This reaction's molecularity would not be defined. The reaction will take place in 2 steps. Okay? Reaction will take place in 2 steps. However, for theoretical purposes, what we will do is we will take that reaction which is the rate determining step of the reaction. Rate determining step में जितने molecules involve होते हैं उसको हम बोल देंगे molecularity. Okay? Now, if you look at the mechanism will have only alkyl halide reacting in the rate determining step, and that makes the molecularity equal to 1. So because of that, you will call this reaction first order, or you can call this reaction unimolecular. How to find for this reaction completes in 2 steps? Ajay Singh, that is the mechanism. Mechanism is again experimental. This is SN1 reaction. ये 2 step में होता है. ये मुझे मालूम है. ये आप किताबों में पढ़ सकते हो. Because ये हमने experimentally identified. Mechanism is experimentally identified. How 2 is equal to 1? Arey, sorry. This is 1, man. I'm sorry. Ganesh. Okay. So यहाँ तक clear है ना? मैं इसको if I write the mechanism, you will be able to understand. So if I take this alkyl halide, so CH3 whole thrice Br, and if I write CH3 whole thrice C plus Br minus, ये रिएक्शन इस तरह से होता है. ओके, द रिएक्शन टेक्स प्लेस लाइक दिस. आप देख सकते हो 2 स्टेप में रिएक्शन हो रहा है. ओके, रिएक्शन टेक्स प्लेस इन 2 स्टेप्स. दिस रिएक्शन इज nucleophilic substitution reaction. Okay, nucleophilic substitution reaction, this is known as nucleophilic. This is step 1, this is step 2. Now if you are being asked to identify what is the rate determining step, rate determining, this is not SN2, this is SN1. So let's try and understand how we are making, why are we calling it SN1. you can see that this is being substituted. Okay, you can see that this Br is being substituted. So Br is being substituted by OH, and so it is known as substitution reaction. Okay, first, what is the nature of reaction? Substitution. Okay, so substitution. What is performing the substitution? It is being performed by H2O. It is being performed by H2O. So H2O is a nucleophile. So this substitution reaction, since is being performed by nucleophile, so I will call it substitution, nucleophilic substitution. But I really don't know that why I should be putting 1 or 2. So for that, I will do an experiment and I will see that which is the rate determining step of the reaction. One way of identifying rate determining step is to look at this reaction and identify kahan pe charge create ho raha hai, where charge is getting created. Now charge is like a headache. Nobody wants headache. Charge is like a headache. Nobody wants headache. So what we can see over here is in this reaction. So this is like the oldest rule in the book. कहाँ पे charge create हो रहा है, किस reaction में, किस step में charge create हो रहा है. So over here it is uncharged, charged, this is charged, this is neutral. So where charge is getting created, where headache is getting created. So remember those steps where charge is getting created or headache is getting created, that will be slow. क्योंकि आप headache लेना नहीं चाहते हो, कोई भी काम करना किसी के लिए अच्छा नहीं है. Everybody wants to relax. So this molecule does not want to break. The moment it breaks, charge is created and this becomes a slow step of the reaction. और ये हो जाएगा fast. If one becomes slow, one becomes fast. If it is slow, how many entities are involved in the slow step of the reaction? One. What is involved? This one is involved. So it will be known as nucleophilic substitution, first order, or unimolecular, because only one molecule is involved, one type of molecule is involved in the rate determining step. So that is the reason we call it SN1. Okay, that is the reason we call it SN1. A similar reason can be given for SN2. Clear? So this is how it works. Slow reaction, headache, yes, correct. Let's look at, so this is the solution. With respect to alkyl halide is 1, H2O is 0. Now let's try to identify for this one. Determine the rate law and overall order of the reaction. Okay. Determine the rate law and the overall order of the reaction. कैसे लिखेंगे इसका? So what are the reactants? BrO3 minus Br minus H plus. So I will write this thing as rate is proportional to BrO3 minus to the power m Br minus to the power n and H plus to the power कुछ x ले लो. Okay, doubling the concentration of BrO3 minus doubles the rate of reaction, so the m will be 1. Doubling the concentration of Br minus doubles the rate of reaction, n will be also 1. Doubling the concentration of H plus increase the rate of reaction by a factor of 4, so this will be 2. The overall order will become 4, 2 plus 1 plus 1, and partial orders with respect to BrO minus will be 1, Br minus will be 1, and H plus will be 2. Okay, the right answer should be this. Answer यही हो जाएगा. So 1, 1, 2, 4. So what you can see, one very important idea that you can get from here, कि whether this reaction is elementary or not, ये पता कैसे चलेगा? What is the total number, total sum of coefficients? 6 plus 5 plus 1, that is 12. Okay, total sum of coefficients is 12, isn't it? Total sum of coefficients is coming as 12, and the order is coming as 4. So molecularity is not equal to the order, so it is a non-elementary reaction. Okay, it's a non-elementary reaction. If the total sum of coefficients is not equal to the order, it will turn out to be a non-elementary reaction. Previous one was also non-elementary. Total sum of coefficients was 2 and the order was coming as 1. So it was a non-elementary reaction. इसमें भी वही हो जाएगा. Total order कितना हो जा रहा है? 4. Total sum of coefficient is 12. So it is a non-elementary reaction. Whenever this matches, it will turn out to be elementary. Okay, so that's a very simple trick that you can use to understand that whether कैसे हम पता करेंगे कि elementary है या नहीं है. Okay, तो आपका order तो आपको experimentally में निकाल जाएगा. Then you will look at the sum of coefficients and then you'll identify whether it is equal or unequal. Okay. So with this, I end today's session. In the next class, we will discuss about rate constants, and we will start with zero order reaction. Please do attend that class. Because we'll take some problems. We'll understand the features of zero order. We'll look at the integrated rate law for zero order and that for first order reaction as well. So today's next session is Newton-Leibniz theorem and summation as integration. 8 p.m. there's a KPY session of trigonometry, and 9 p.m. is a ecology and environment session by Vani Madam. So the notes will be there in the description section. So please do attend these, and we'll continue from here in the next class, and please do join us in the next class as well. Bye bye guys, and have a lovely time.